Yeah, it's recording. Go ahead and click this. We don't give an echo. Close it. Yeah, close it. Now you want.
At least it's streaming.
And it's. Yeah, it is recording. And so. Oh, yeah. Yeah, and now if you want to project anything to you, can switch to the camera if you want to share anything there.
Okay, great.
Right.
Thank you. Okay. You have some papers for me?
We need help.
Oh. Okay. I have help. I copied out the answer with. They wanted 12 by 12 matrix to solve. I don't think so. I'll let you look at it. But it's basically part one that I want. I think is well within our range of doing part one.
Yes, yeah, part two. Yeah, part two is like.
Yeah.
Wow.
Yeah, everyone's. That's why I was looking so hard for that. What is something obvious too? There's not the back of the book. Yeah, so they show a 12 by 12 matrix. We need the first part. So the first part is right here. Short, sweet, feel good. The other part. Let's just say. I don't know how to put in 12 by 12 matrix into Desmos. I think they're limited to like 6 by 6. So. Yeah. So I want an answer for number one.
This one. That first one, that's not too interesting. Yeah, thanks.
Dang. Oh, yeah, she turned her into elections. That one, I haven't seen it. Very good. This is not really good. Julian, Evan. Okay. I won't call anybody's grade. This might be one we drop. Oops. So, all right. Get that number one done right now. So there. With your partner, you have to find them. I don't know. I gave you the list of who you're working with. Need a piece of paper, both names on it, A, B, C, and D. Lauren, you. You guys are all done?
I thought it was due like beginning of class.
Oh, yeah. I just put your names on it, and if you got them, that's great. If not, let's put your name on it and hand it in. No.
Yeah.
Yeah, those look like some of the numbers I had. It was.
It's just.
I did an approximation of the draft.
Yeah. Good job.
Yes.
Thank you. Blue, who's your partner? Oh. Okay, I will write his name on there too then. Thank you. Thank you much. No. Just both your names. 30. Any other group? Not in again. Okay, I've got me at least one more group. Okay, here's a problem that's from section 3.1. We need one more thing. We get for an answer.
Isn't it just 2 pi x, which is e to the pi is a constant?
Yeah, e to the pi is the constant.
And so then the derivative of x squared is 2x.
Three x in a bit.
That would be next to not one. Wouldn't that be 6 to the 5 power x squared?
Now you have to leave. 2 to the pi is some irrational number. We can't multiply. So we just have to have 2 pi. And then
3x to the second, and then plus 1x to the third.
okay, so I'm doing a subtraction problem. I'll even try it. A different variable. I said it's five. All right, everyone, let's hear it.
Is it equal to T minus 16?
Almost. There's a little bit more involved. Yes, there'll be a 16T times something. Right?
The natural log.
Yes. The natural log of 16.
It's much.
If you're gonna take the derivative of an exponential function, it is the natural log of, the base times. Okay, so using t, still variable. All right. Now. Let's see, I have 15x to the 4. Okay, this should be obvious, but this is section 3.2. We're getting into a product and a quotient rule. It's multiplication and division. Okay, this is what you should not do. Go ahead and try it. And you'll see why we don't take the derivative of a piece and multiply it by the derivative of a piece. So right here, it should be hopefully obvious. Oh, 3 to the 5th. Okay, sorry, I want it to come out the same. So make this 3 squared and x cubed. Okay, just so it matches 3x to the 5th, 3x squared times x cubed. They should do the same. Okay. So 3x squared and x cubed. I was looking at the answer. Okay. So our pen, what's the derivative of this first one?
6x.
6x. And Michael, second one, derivative of x cubed.
That's gonna be 3x squared.
3x squared. Okay, so what happens when we multiply them together? Yeah, we get 18x cubed. We were looking for 15x to the 4th. They don't match, so basically, when you have a multiplication situation, you don't just take the derivative of the first, the derivative of the second, and you multiply them together. It's a little bit more involved. I know there's a graph, a picture of a rectangle in your book. I don't like the explanation goes with it very well. Do you mind if I just give you the formula? So if I want to take the derivative of a function times a function. Always makes me think of the word big. It's just a function f times a function g. It will be the derivative of the first times the second. Okay, I thought I wrote q for a second there. Plus the derivative of the first times the derivative of the second.
You can't just multiply now.
If it's something like e to the x and x cubed,
So it's not simple then.
so far, yeah. So let's look at this problem we had with, we had a 3x squared times an x cubed.
Right.
Okay, so if we take the derivative of the first, that was, I think you told me a 6x. 6x, and then I don't touch the second one, it just is there. Not gonna do anything with it. Then I'm gonna add the first. And now I take the derivative of the second. Which was. Can't even see that far, where do we get it? Times 3x squared. So. This will be. So this will give us 6x to the fourth power. And the second piece will give us 9x to the fourth power. And we'll get 15x to the fourth power, which is what we're looking for. Okay,
Oh, never mind.
derivative of the first times the second. Plus the first times the derivative of the second. That's why I was trying to write it in different colors. That's why 6x is red and the 3x squared is red. That's pretty simple, maybe. So let me throw in one that's in 10 to the x or 16th to the x or something. Okay. Derivative with respect to r. That was on the problem. R of 3e to the r times r to the, let me make it 7th power. Just so you don't get confused. Okay. Your baby, go for it. See what you come up with. And I'll close the parentheses. I don't know how many pages of notes I took trying to. work on that second. Okay. Don't feel like you need to simplify or factor stuff out when you get done, because you can make mistakes there, and I actually enjoy seeing how you got your answer. Just saying that right now, we're not gonna simplify anything. Okay. Rhett. What's the derivative of the first one? 3e to the r. And then we'll just multiply by the second. Not good. R to the 7th power. And then blue, what's the derivative of the second? 7 times r to the 6th power. And just keep it in order. 3e to the r. If you leave it like this, I'm good. I can see exactly where your answer came from. If you actually combine, 3 times 7 and get 21, I'm good with that. So the both work. E to the r to the 6th power. Great answer. You don't need to factor stuff out or anything else like that. Okay, it's a great answer. Either one, put a box around it, you're done. I don't care which one you pick, but you're done. What do you think? Easy, hard, medium?
Just be easier just to multiply it with the parentheses and-
Can you?
Yeah. all right.
You can. Yeah. You could. It was pretty obvious. Yeah, we could have multiplied it first and then taken through. This one, we can't. It's just what it is.
Yeah, you got shut down real quick. Well, it took me forever to think about.
Hey, it was a good question worth thinking about. So, I have one more. Right now, I'm sticking with basic exponents. Later on, we'll get to a little more complicated exponents, but that's another rule. We're just doing multiplication and division. So this one, I'll go back to X. Okay. So I'm trying to record for Sam, and I don't know if you can see the board, so I'll just read it off for him. Derivative of e to the x times 3x to the 1/2 power. Let's see, ready? Derivative of the first.
So X, E. E to the X.
E to the X. One of those nice ones. Yeah. And then we just write the second one, what it is. Don't touch it. 3x to the 1 half. Okay, let's get the second part in there. Gosh, haven't we done yet?
So you just take the original function,
Oh, sorry.
yeah, you take the original into the x. And then you would multiply it by 3/2 times x to the -1/2.
Cool, managed to fit it on the board. Okay, great answer. If you want to get rid of your negative exponent and put it on the bottom, it's okay, you can do it. But, you know, I'm happy with this. You haven't messed up and you've shown me your work. Sometimes can get a little tricky, if no one passed this. But, you know, if you want to write 3, I'd probably write it with the e next, e to the x, square root of x, plus 3/2 e to the x divided by the square root of x. That's fine as well. Don't go any further. We're not trying to rationalize the denominator or anything. We're done, put a box around it, call it good. There. Okay. Now, division.
Same thing, just subtraction.
Almost, it's almost. The problem is, we're gonna need one more step called the chain rule. And we don't have it yet, so I'm gonna give you the formula. So we get. Well, let's do a division problem first, that you know the answer of. Derivative of. Let's see. 6x. To the 5th power divided by 2x to the 5th power. Okay, so we know what it is to divide. So we know its derivative would be 15x to the 4th. Well, oh,
Because when is that whole thing?
yeah, they would just go to 3, wouldn't it?
And then. the derivative of that.
Okay, but what if it was 10? 10. Okay, that will be 3x to the 5th. Okay. So you know that we know the derivative of this. We've seen it 3 times or twice or something. So we know we're looking at the derivative of 3x to the 5th, and we know it has to be 15x to the 5th. We're just that good. If we wanted to do division, and we're thinking, okay, multiplication like this, and we have an addition, maybe subtraction would work. Okay, I'll tell you right now, it doesn't, because it needs another step, but we'll just walk through it like subtraction did work. So let me just put a not equals right here. I can see why it doesn't. Okay, so the derivative of what was on top. So derivative of 6x to the 10th. Harpan, you're smiling. What is the derivative of 6x to the 10th power?
16x to the power 9.
Okay, and then our function, our second function will just follow along. And that was 2x to the 5th. Okay. So I'll keep the first one, 6x to the 10th times. Now we need the derivative bottom, the 2x to the 5th thing.
To next year.
Okay, that looks like 120 x to the 14th minus 60 x to the 14th, which looks like 60 x to the 14th. Okay, this did not work. So what if instead of multiplication, we tried division? Couldn't hurt. We already have the numbers. I mean, it's not going to work. I'll tell you right now, just make sure your equal sign has a little slash through it, not equal to. So it's closer to the what we're looking for. So we have 60 x to the 9th power divided by 2x to the 5th. Subtract 6x to the 10th over 10x to the 4th. Okay. Just put a division here. So I'm gonna put a big not equals in front. But we're closer. We are closer. Because I mean, at least this part, 30x to the 4th power. That's closer. Unfortunately, the other piece is what, 0.6 minus 0.6x to the 6th power. So we're not quite there. And now I get to pull back the curtain and, you know, pull the rabbit out of the hat, whatever you want to call it. The formula, which I can't explain because we haven't done the chain rule yet. Derivative with respect to x of a function divided by another function equals the derivative of the first times the second. Subtract the first times the derivative of the second divided by that function squared. Woo! We were close. We were close. Just the chain rule is what puts the squared on the bottom. Because let me just show you really fast. If you have x to the -1 and you take its derivative, then it's x to the -2. Let me put a negative out in front. I think I might. Okay, so 1 over x and 1 over x squared. This idea is just saying if there's something on the bottom, we'll end up scoring it eventually. But that's the chain rule. So yes, there is a negative out. So again, for that. So it's that idea. All right, let's see if it works with this function I tried to break apart. derivative of. Just put a negative in parentheses to begin with. Derivative of 6x to the 10th power. Haven't picked on Jack.
60 else.
And then we'll just leave the bottom one alone. 2x to the 5th. Subtract. Now we need the derivative of the bottom, the 2x to the 5th. Julian?
Yeah.
Okay, sorry.
So what?
Derivative of this one. There you go. And then we just leave the second one in there. Okay. I'm running the backwards order, but 10x to the 4th and 6x to the 10th divided by 2x to the 5th squared. Division is the most work. Okay, start simplifying. Equals, okay, 120, sorry, 120 x to the 14th minus 60 x to the 14th divided by, what do we have? Yep. 4x to the 10th power. Ah, because we just multiplied our exponents together. Okay. A lot of negative 60x to the 14th. Okay. We don't have it there, so we don't have the negative. The negative goes with the derivative of the bottom. This one was the derivative of the bottom, so that's the negative. So I don't need an issue. Okay. Sorry about that. Ugh. Yeah, you guys can erase it, cross it out, whatever. Sorry about it. Okay. So we'll get rid of that negative out in front. Okay, so 60 x to the 14th divided by 4 x to the 10th. Equals. Okay, someone else. Who wants to write it on the board? Tired. Okay. Woohoo, good catch. I won't say it was a good throw, but good catch. What do you get? Thank you. We come back to what we had, 15x to the 4th power. So it looks like maybe we were really close right here. We just didn't have its division. That's why we're huge. X to the 14th power. Okay. It wasn't divided by whatever was on the bottom square. Okay, we have 10 minutes. Whoa, Jesus. Okay, your turn. Let's throw in some. Okay. So 2 terms. 2 functions that we really can't divide first. Oh, it's not equals. When we get done, it'll just be a kind of a messy fraction with a subtraction sign. Okay. So for Sam, who may or may not be able to see the board, it's the derivative of 2 raised to the x power divided by x cubed. Sam's the football player in the class. So I'm trying to record so he can at least follow along. Okay. All right, so derivative of the first. Who hasn't picked that? Lauren. I picked any. Derivative of 2x, 2 raised to the x power.
2 raised to the x times the natural log of 2.
Yeah, and we usually write it in front because it's a constant. And then we'll just multiply it by the bottom because we don't change the bottom. Then we subtract. And the first will stay the same. So in this case, we'll just have 2 to the x power. And we need to multiply by the derivative of the bottom. Rhett, I guess we'll go back to you. Derivative of x cubed. 2x squared. And then we're gonna divide, so woo, that's you. We'll just take the x cubed and squared. So x cubed squared. That's a great answer. I will accept the answer. It's nice. Yes, I can simplify a little bit more, but right now I haven't made a mistake doing any simplification. Okay, got it.
So if we were to do this on our homework per se, can we throw that in there or? are we
I think you might actually have to take the square out. But otherwise, I can touch it.
Like on the bottom?
Yeah,
Oh,
so what would this be?
that is actually.
Yeah,
Yeah.
so we just replace this with x to the 6th power. And yeah, I wouldn't, no, that's it. Okay, put a box around it, you're done. That's it. Okay. If you think you've got it, you're free to go. Want to see some more examples? I will work some more examples.
As for the homework tonight. Well, I guess that's due on Monday.
Yep.
Are you gonna assign 3.2? So we have right now 1.5.
Yeah, I didn't realize it wasn't. Okay, I will assign it. It could just be sitting there in limbo. But yes, I will assign it.
Wait, when will that one be due?
This one, 3.2, it's due on Monday.
No, the one you were just.
1.5, I don't know when it's due. I'm not too worried. It's a review of natural logs.
Yeah, she said there was another one out there. Another one.
3.2 is supposed to be up. I don't know where it is. I'm gonna go find it.
Oh,
Sorry, Arpan, I didn't get notes. I was looking up the answer. Okay, good. Oh, 1.4. Okay, so they're saying they want to compress vertically, so that what's inside is compressing the up. This is the side of the X, so that's it.
So what can you do?
So try it back to 5.
5?
Try.
Oh. I was just trying that. Just putting 1.5 sometimes. It should be correct, but it factor of 5.
Yeah, when they say the factor, then they just, they want to know how much. Well, I'm compressing it by 5, or I'm multiplying by 1/5 are the same.
And this one I didn't get this question. What's this?
Okay, okay, let's see what it says. What does it want you to do? Okay, okay, they're trying to talk you through your calculator and how to make a tangent. So that's what's going on.
This exercise.
So the exercise is.
Thank you, have a good weekend.
Okay, it should be kind of like an X.
You want me to start
Oh.
calculating?
Sure. Yeah. Oh. Actually, they should be the same line, shouldn't they? Because if A2 is the reciprocal of 1/2. Yeah, so 1 divided by 2. 1 over 1/2, that's 2. So they should be the same. And then, and that should be the same right there with 1 over 4, 5, 1 over 5.
That means answer is 7, 4, 5.
I just say, if you're taking the reciprocal
Mhm.
of the reciprocal, you'll get the same answer.
Yeah.
Or the same number. That's what it is.
No, I was just trying to look that if they are written explanation or just the numbers.
Just say they're the same.
Then I guess it's 7, 5, I guess.
Okay.
And how do you verify the observation?
Let's see, what was the formula? There's gotta be an X in there somewhere. Oh, they're putting this to the X power? Is that what they're doing with that? A to the X, A2 to the X. Okay. So basically, can you, sorry, the first one was 2 to the X power. And then the second one was 1 over 1/2 to the X power.
Yeah.
The reciprocal of the reciprocal of the reciprocal. You'd be right back where you started.
So that means 2 to the power X.
I mean, what can you say then? 1 divided by 1/2. Okay, you have one piece of paper. You divide it in half. How many pieces of paper do you have?
2.
There you go. All right, I'll go ahead and stop the recording. I hope it was